Over the summer, I had an engineering internship at MA Ford Manufacturing Company, where we specialize in making countersinks and mills, reamers, and drills in-house and exporting them to numerous companies. The project that I spent my summer on was coming up with a solution to an issue that we had involving our coating machine. This picture is an example of what the trays look like before they go into the coating machine. In order to place the tools on the tray, they had to sit in a casing. This video shows what those casings look like. Because of the various sizes of the tools that we make, there are different sizes of casings, as you can see in the video. Over time, after many uses in the coating machine, the casings would become unreadable because of how much coating had built up on them. In order to read the casings, we had to sandblast them. The only way that we were able to do this was to hold each individual casing by a pair of pliers and sandblast them. And this was a waste of time and resources. I was tasked with designing a solution to this issue. I spent a lot of time in SolidWorks and out in the shop brainstorming ideas. The rendering that you are watching is ultimately what I came up with. This system would allow you to sandblast 20 to 30 casings at one time. You can slide the casings onto each of these rods, and once it's all put together, you can turn every single rod at the same time, making it easy to sandblast the entire surface of each of the casings. A lot of these parts that I designed were custom parts, and therefore I had to make them in the shop. I used different sized rods and metal stocks to either put in the lathe or in the Makino V55 3-axis milling machine. One of the challenges that I faced was making the system easy to spin. I incorporated the use of gears into my design, and that way you can turn one gear and the rest would turn with it. But the fine sand particles and the vacuum of the sandblaster found its way into almost anything, and specifically for me, the gears. So I had to engineer around the sand. I made a tower that the gears sit in, which was airtight and therefore keeping the sand out. Another issue that I faced was a different sizes of rods. My solution to this was simple. I made a spacer with step downs that allowed any kind of spacer to slide onto its respective steps down. Not only did the final system do its job really well, but it saved the company time and resources. There were a lot of learning experiences throughout this internship at MA Ford. Throughout my design process, I had a budget which allowed me to explore creative ways to recycle leftover material in the shop already. I worked alongside veteran engineers that taught me the importance of using the correct material for the correct application.